Have you ever wondered what is the real process that turns crude oil into the fuel that moves the world? In a world where nearly 800 million vehicles travel the roads every day, approximately 7 billion liters of fuel are needed to keep gas stations in every corner of the planet supplied with that essential and volatile liquid. This process, extremely complex and equally risky, invites us to reflect on the steps taken to transform crude oil into the fuel that powers our engines: gasoline. The origin of oil dates back to ancient times, when remains of plants and tiny marine organisms were deposited on ancient seabeds. Over the centuries, this organic material was buried under layers of sediment and, subjected to intense pressure and high temperatures, underwent an extraordinary chemical transformation. Thus, after millions of years, what was once organic matter turned into black gold, a resource that, despite emanating an odor reminiscent of rotting eggs, holds such extraordinary value that it drives entire economies. Under the relentless Texan sun, in conditions of high humidity and scorching heat, a day of arduous work begins as specialized teams drill new wells. This process, which demands millimetric precision and extraordinary coordination, allows for the opening of multiple extraction sites each month, ensuring the collection of more than 900,000 barrels of crude oil daily. Leading companies in the sector, like Occidental Petroleum, maintain a drilling pace of roughly 1 well per day, demonstrating that in this endeavor, human and technological effort is ceaseless. The location of potential oil reservoirs is determined through advanced seismic techniques, which allow for the detection of underground formations rich in oil and natural gas. However, no matter how sophisticated the technology, it cannot completely eliminate the inherent risk that a well may turn out to be unproductive. Once a deposit is identified, the crude is transported to a refinery where it undergoes transformation processes to convert it into gasoline, diesel, aviation fuel, and other essential byproducts for multiple industries. The task of extracting the crude faces numerous technical challenges. In areas known as thermal basins, where oil is concealed at depths that can exceed 4,000 meters, this resource is confined within ancient rocks, some over 542 million years old. To reach these reserves, powerful engines are employed to drive enormous drill bits equipped with diamond-tipped cutters. The friction generated while cutting through the earth notably increases the temperature, making it imperative to continuously pump high-pressure water to cool the cutting head and prevent the machinery from overheating. The drilling process requires strict regulation of pressure. If it is insufficient, the drill bit fails to cut through the substrate. On the other hand, if the pressure is excessive, the equipment may suffer irreparable damage or even trigger explosive gas releases. During drilling, the technical team periodically adds sections of pipe using an automatic double wrench weighing 5 tons, repeating the cycle every few hours in a continuous 24-hour effort to ensure steady progress at an approximate speed of 5 meters per hour. Initially, the natural pressure of the oil trapped in the rock aids in pushing the crude up through small openings in the drilling pipes, allowing it to reach the surface. However, since this pressure does not last indefinitely, specially designed piston pumps for deep wells are employed. These pumps, whose mechanism resembles that of a giant metal syringe, convert the circular motion of the engine into a vertical thrust that extracts the oil, transporting it to a collection point where it can be further processed. Once each well begins to feed its extraction pipe, all the crude, mixed with carbon dioxide, hydrogen sulfide, and natural gas, is directed toward a central gas removal system. At this stage, impurities are eliminated to ensure that only the purified crude continues on its journey. The pumps and the network of pipes work together to maintain process efficiency, allowing this precious resource to be collected consistently and with minimal losses. Subsequently, the oil must be transported over long distances. For this, a network of pipelines spanning up to 1,000 kilometers is used, connecting the reservoirs directly with the refineries. The largest refinery in the United States, located in Texas, features a network that surpasses 8,000 kilometers of pipelines and covers an area of 10 square kilometers. enabling it to process more than 562,000 barrels daily. The vast scale and inherent noise of these facilities require that the 4,000 workers annually use over 1 million hearing protectors. In this gigantic plant, crude oil is composed of a complex mixture of hydrocarbons, each characterized by a certain number of carbon atoms and distinct molecular weights. This arrangement allows, through a meticulous separation process, for the obtaining of products with specific properties. From propane, considered the lightest component, to compounds destined for asphalt production. In addition, hydrogen sulfide is extracted and processed into sulfur, a raw material for fertilizers, clearly demonstrating how each fraction of the oil is exploited. Distillation, the process by which the various components of oil are separated, begins by heating the crude until it exceeds 370 degrees Celsius. As it rises, the vapor cools and the molecules condense according to their weight. First, the heavier fractions deposit at the bottom of the tower, while the lighter components, such as gasoline and kerosene, rise to the upper zones, from where they are extracted using precise siphons. On average, for every 191 barrels processed, 88 liters of gasoline, 48 liters of diesel, 26 liters of kerosene, nearly 7 liters of propane, and 32 liters of other byproducts, including lubricants and raw materials for the plastics industry, are obtained. The production of gasoline is so substantial that, comparatively, it would allow a car to make up to 770 round trips to the moon. The quality of the fuel undergoes rigorous testing on engine dynamometers, where old engines are used to evaluate the propensity for knocking. During this process, the behavior of the fuel under compression in the cylinder is analyzed, and based on those data, the mixtures in the refinery are adjusted to perfect the final product. When the refining process is complete, the gasoline is channeled through an underground pipeline system to strategically located distribution terminals. From there, large tanker trucks transport it to service stations. However, the act of loading or unloading these vehicles carries significant risks. A mistake in the process could trigger severe explosions, as the metal of the truck body might produce sparks due to static electricity. Therefore, strict safety measures are implemented, such as grounding through special cables and activating sensors to prevent overfilling, in addition to secondary systems that capture any residual vapor and stop it from dispersing into the environment. Every day, around 4 million liters of gasoline are mobilized through this sophisticated logistics system, which culminates in the unloading of the fuel into large tanks at gas stations. This process, despite its high technical demands and expensive safety network, is essential to ensure that the final product arrives in perfect condition into the hands of the consumer. Thus, when you refuel your vehicle, you can't help but recall the complex machinery and advanced technology involved in transforming crude oil into that precious liquid that powers our societies, and, despite its high cost, represents the fruit of an interconnected global industrial chain. While it may be astonishing how large and meticulous the process of obtaining gasoline is, this narrative also invites us to contemplate the other side of the coin: the intrinsic relationship between governments, producers, and the value of money. For those interested in figuratively discovering the process behind the creation of the dollar, you will find a complimentary link in the description, as well as in the first comment. Don't forget to leave a like if you found this content enriching, share it with friends, and subscribe to the channel by activating notifications to continue delving into these fascinating subjects. The journey through the transformation chain of oil, from its extraction from the Earth's depths to its conversion into the fuel that powers vehicles and machinery, is the sum of thousands of hours of work, cutting-edge technology, and extraordinary coordination among specialists in various fields. Each phase, from geophysical exploration to the implementation of innovative distillation techniques, reveals a world where science and engineering come together to convert a natural resource into a product vital for modern society. Ultimately, the journey of black gold is a tale of ingenuity, precision, and passion. It is the story of how, through a series of complex processes and the meticulous coordination of numerous teams, oil, resulting from millions of years of natural transformation, becomes the liquid that drives the modern world, keeping everything from transportation systems to key industries of the global economy running.